Joshua, I want you to be the lead. It doesn't, being the lead does not necessarily mean you should be the one organizing it. I'll do that. But I'm talking about when it comes to the submission, you are the lead author. Then all other people will follow.
Yes, please.
Are you okay with that?
Yes, please.
Okay. So the digital twins in sustainability, Joshua will be, and then the rest of us will follow. But when it comes to the work, we are all going to work together. And then the subsequent papers, as I discussed with you, we also nominate another person to be the lead. Because the other paper, which is the green building, the green buildings paper, which like we are developing now, is God's Way, who will end up being put as the lead author. The one which is the PPP and then the Gen AI, generative AI, that one is being led by Benjamin. Benjamin is the lead author. Benjamin, are you here?
Yes, Doc, please, I'm here.
Yeah, Benjamin is the lead author, which Benjamin knows is under review. So what I have said is that everyone will end up having at least one paper being the leader. But I mean, if we are going to stay together, all the subsequent papers is going to be the same. Subsequent papers will continue to rotate. One person will be nominated as the lead author. One of us. So it means that when you are working, see the paper, see the work as your work. Don't see it to be like we are writing the paper for someone to be the lead author. It will definitely get to your turn where you become a lead author. But even one of the things I always tell people is that, to me, I don't even have issues with anyone who will become a lead author. What I am interested in is to find myself on the paper, whether I'm the 7th or the 8th or the 10th author. I don't really mind. The reason being that when it comes to paper citations, if Benjamin is the lead author and I'm the 7th author, and Benjamin end up getting 10 citations, I will also be credited with 10 citations. Even though if you look at the paper, you can locate me on the 7th position or the 10th position. Yeah, so don't think about why am I not the lead author? Why is this person here? Why is this person there? The most important thing is for you to find yourself on the paper. That's the most important thing. I understand that sometimes when you are looking for some positions and scholarships and all that, some of the people ask for the number of papers that you are a lead author. Yes, it's there. It's good. That is why even I brought this idea that we rotate. But aside that, aside somebody asking you the number of papers that you are a lead author or an organization asking you, when it comes to citations, those things don't matter. We are all going to get the same number of citations. If Noah end up getting 10, I'll end up getting 10. Gilbert will end up getting 10. Joshua will end up getting 10. Everyone get 10, 10, 10, 10, 10. Nobody will get more citations than the other person. Okay, so without wasting time, let me go into this. So straight away, the AI, sustainability, and digital twins book chapter, Joshua is the lead author. But the work, I'm going to share it in such a way that everybody will do something. Now we are 7 or 8 or so. So everybody will end up writing between 500, because when I did the calculation the last time, between 500 to 700 words maximum, which is good enough. 700 to 500 to 700 or so will end up giving us about 5,600. If we are 8, 700 by 8 is 5,600, excluding references. If you add references, it will push us to about 7,500, 8,000 words. And normally having that is even too much. Most book chapters ask for between 5,000 to 8,000 words maximum. Most book chapters between 5,000 to 8,000 words. So we are far We are far gone. Okay, so I will share that on the page and then we start working on it. Now let's come to our meta-analysis. So with the meta-analysis, you shared, Goswe shared what he did with us. And I guess all of us or many of us, we have looked at that. Yeah, for the sake of Gilbert and Noah, I will take my time to go back a bit to explain some few things before we come back to do the analysis. Okay, so to do a meta-analysis is very simple. You start with, can you see my screen or you can't? Please, can you see my screen? Can you see my screen?
No.
No, please.
No, please.
Oh, okay, I'm sorry. Let me share it again. Okay, to do a meta-analysis, the foundation is just the same as doing a normal systematic literature review. So the foundation of a meta-analysis is systematic literature review. The reason why I say this is that anybody who is able to do a good meta-analysis must have a good idea, a grasp over the systematic literature review. Because out of the systematic literature review, you go further and apply some mathematical formulas and computations, and then you get your meta-analysis. So normally, if you see most of the meta-analysis papers that people have published, which we looked at some of them last week, or the last time that we met, you can see that they combine both the systematic literature review and the meta-analysis. The systematic literature review is done first, and based on the systematic literature review, they go ahead and do the meta-analysis. Joshua, were you able to look at this? I think you said you did.
Yeah.
Okay, good. So for you to understand, so Gilbert and Noah, for you to understand systematic literature review and the meta-analysis, please go through this. I'm trying to try to summarize something so that we don't waste too much time. Other than that, so I have to go back all the way from the beginning, and it's going to take a long time before we move on. So try and read this. So this website,
Okay.
come to Prisma website, and here you get to know what systematic literature review is about. So what is systematic literature review? I'm going to use this diagram to explain it, to make it simple so that we get this and then we move on. I'm just trying to save time. Yeah. So this is how systematic literature review, and when you go further, you do meta-analysis. This is how they are done. First, if you want to conduct a systematic literature review, you need to have your keywords. Normally, the keywords come from your research topic or your research question, the question that you are investigating or the question that you want to address as far as your work is concerned. Out of the research question or the research topic, you extract what we call keywords. And the keywords, you put them into what we call databases. Databases in this context is just like a warehouse or your storehouse or your storeroom or in a normal room, your house. And before you enter into any house, what do? You need a key, right? You can't just enter into somebody's room without having the person's key. You can't enter into somebody's house, somebody's room, or somebody's warehouse without having a key. So the keywords here are just like the keys, just like any key that we know that you use to enter. So when you enter into the databases, you'll be able to extract important documents, important information from there. But the question then is what are these databases, or what are they, or what are examples? So the databases, we have examples like Google Scholar, which many of us we know. We have used them for our work. So Google Scholar is a database within which you put your keywords, or within which you apply your keywords. And then we have another one called Scopus. We have another one called Web of Science. We have another one called EBSCO's Host. We have another one called PubMed. We have another one called Cochrane, and the rest. All these are databases. Or it could also be, when the database, it could also be just registered. It could be a government database or an institutional database. The ones I mentioned are more academic, scholarly databases, but we also have databases which have been designed by institutions like World Bank, IMF, UNDP, Ministry of Finance, Ghana, Ministry of Development, Ministry of Science and Technology and Empowerment, and whatever. They have their databases online. Okay, so you apply these keywords, and the keywords, based on the application of the keywords, certain important documents will be retrieved or will come out of them. And when these documents come out, because you are dealing with so many databases, some of the documents will appear the same. So if the document is numbered number 1, you may see number 1 document in Scopus at the same time Web of Science. And when they happen that way, we call them duplicates. A duplicate means something has happened once. You are seeing the same thing appearing in multiple or different databases. They are called duplicates. So the duplicates, you have to take away the duplicate, because you can't repeat the same thing. So you have to remove duplicates. And then some of the documents too, it's possible you may not be able to identify them in terms of their full PDF. And I think many of us, we have experienced this before, especially in Ghana. There are certain articles that you try to open and it's difficult to open, or sometimes they will even tell you you have to pay money before you can get access to it. For such, you have to take them out of your list, because you can't review such documents, because you can't review something that you don't have full access to. Okay, yeah. And then some also go ahead to do what we call citation searching. Citation searching is where you look at the articles, each of the articles, or the important articles, you go to their reference list. And based on the reference list, you select important articles from there. So I'm going to show you one. Like if you look at one of the articles that we have just published with Joshua and Benjamin, if you check, this is our reference list. Can you see our reference list or our references? So based on these references, you can just go through the articles in the references and then select some of the articles that you think they are important to the work that you are doing, or they can help you to address your research question. Okay, let me come back. So what do you do again? So once you are done with this stage, the fact of the matter is that, or the truth is that, you don't have to put all these things in there. This is just an extended version, this diagram. Yeah, because this diagram it doesn't mean you have to put everything, because I've seen some papers where the authors concentrated on the first box and then they move on to the next box. They didn't look at all these things. So it depends on what you are doing. I'm just trying to explain the entire thing to you. You don't have to put every box here. The second stage, so that stage is called identification stage. The second stage is called the screening stage. This is where you do the actual screening. So after removing the duplicate and all that, now you do the proper screening. The screening, for you to do a proper screening, you need to come up with what we call eligibility criteria. Eligibility criteria, which is also called the inclusion and exclusion criteria. Inclusion and exclusion because you have a target. You have specific documents that you want to see, you want to retrieve, you want to identify, to use for your work. Okay, so you establish that first before you even start the screening and everything. So the whole of this stage you screen based on your eligibility criteria. So what are some of the eligibility criteria that you can set? Let me try and see whether I can get one of the articles that's I think Joshua, this is our paper, circular economy.
Yeah.
Yeah, that in that paper, we set the inclusion and exclusion criteria. Good. So this is the inclusion and exclusion criteria in step 2. What did we say? We said that an article must comprehensively cover circular economy in the context of PPP projects to be included in the analysis. So if you are going through the articles, the document that you have retrieved from the databases, and it didn't talk much about circular economy, you have to take it out. But if it talked much or it gave a comprehensive analysis about circular economy in the context of PPP, you include it, you retain it. They also said that the document type should, the document type considered in this review is journal article. So the articles that you have to use, that is our inclusion criteria. We said the article must be a journal article. But somebody may do another review and say, I want books or conference papers. But in our case, we said books should not be included. Conference notes, short essays, and all that should not be. Then we also said that an article should be published in English. If the article is not published in English, it should be excluded. So all articles that you identify which are in Spanish, French, Chinese should be removed. So this was our inclusion criteria. We retrieved 469 articles. And then we applied these 3 criteria to it. What happened? After applying the 3 criteria, we ended up having 42 articles. So out of the 469 document that we identified, okay, so it's here. Okay, good. This one is, can you see my screen? Yeah. So out of the 469 articles that we identified from all these databases, Scopus, Web of Science, Google Scholar, PubMed, JSTOR, EBSCOhost, and ProQuest, we applied the 3 criteria to the 469. And what did we see? We ended up retaining only 42 articles. We did our quality assessment and then we did analysis. And that was the end. Okay. Yes. So these steps, they are involved or they are included in what we call systematic literature review. And the systematic literature review, we have many. Some come with 3 steps, some come with 2 steps, some come with 5 steps, some come with 6 steps, 7, whatever steps. It's up to you. Now that you are done with this is systematic, normal, systematic literature review, which is more of statement. From here, you need to apply. Okay, so the same diagram is here. I just don't want to bother you. The one I showed you is almost the same as this, or is the same as this. It's the same, actually. It's the same. Now that you have your 42 articles and you have retrieved information and all that, now you have to go ahead and do what we call meta-analysis. The meta-analysis is mathematical, it's statistical, it's quantitative inclined. Whilst the normal systematic literature review, you can just do your normal review, you retrieve important information through what we call qualitative content analysis or qualitative thematic analysis or any of the qualitative methods. You can do that. So in most cases, most scholars see normal systematic literature review, SLR, as a qualitative method. But the meta-analysis part, which is the next part, is quantitative inclined. Why is it quantitative inclined? Because with the meta-analysis, you have to apply mathematical, statistical, quantitative methods in order to get it done. For meta-analysis, you can apply thematic or content analysis or ethnographic approach, or any of the qualitative data analysis that you know. You can't do that with meta-analysis. Meta-analysis is purely quantitative. Okay, so I just want to show you something that we did. And I'll encourage you and Gilbert of this article. I'm talking about Noah and Gilbert. Okay, where is it? Yes, I've shared this article before, but I can also share it again. Should be available. Sorry. Oh, really? They have put a listing on it. Sorry. They have put okay, let me take it from my let me take it from the original source. Okay, so this is the paper. So in this paper, just like what I told you, we went through the same approach. We searched for the articles, we applied the eligibility criteria, we selected the articles. But when it came to the analysis, that's where we applied the meta-analysis or the meta-analysis method. So the meta-analysis, what did we do? Okay, so I've explained that here. Okay, so this is what I said. The meta-analysis was undertaken with a selection of random effect model, and instead of the fixed effect model. I'll come down explain that. Okay, I think I didn't explain that much here. But with the meta-analysis, what we did was that one, we looked at papers or articles that were conducted in the past with what we call cross-sectional design, or papers which were conducted with quantitative research design. And when we say quantitative research design, examples of quantitative research design include conducting a study with a survey. A survey in this context, I mean questionnaires. Or a study that you conduct where you use purely secondary data. Purely secondary data in this context, I mean econometric data, or you use financial information or statistics. That kind of study is included, or they are included in meta-analysis. Those studies are included in meta-analysis. Any study that is not based on quantitative research design is excluded from meta-analysis. And the reason why we do that is that we want quantitative figures, mathematics, words, calculations, computations. They are the ones that we need. Okay, so the last time that we did this, when we met, I don't want to bother you too much, but the last time that we met, we went through the steps we have gone through the steps from one, where from one. And when I say from one, in this paper development, we are looking at meta-analysis of the barriers of green buildings in Ghana. So what did we do? Based on this topic, we came up with keywords. And the keywords, we put them into the databases. And then out of the search, or after we have put them into the database and we searched, we were able to retrieve a certain number of articles. And those articles, we have reviewed them. So, Godsway, can you talk? Hello, Godsway. Is Godsway here? Hello?
I don't care. His speaker is on mute. So.
I don't know whether he's here or he's not. But I wanted him to take us through how he did it. Briefly. I just want him to explain so that yes, Godsway.
Yes, Godsway. Yes, please, I'm here.
Can you take us through what you did?
Yes,
with retrieving the most important papers?
Yes, I can.
Yeah, briefly.
Okay. So after you sent us the Excel, the files in Excel from Web of Science and then Scopus, I matched the two information, and then I looked out for the duplicated, informations, and then I had to delete some of. I had to delete them, and there were about 42 of them. There were 42 studies in all, but after doing taking out the duplicated studies, we were left with about 20 something.
21.
So 21. Okay, 21. I'm currently not with my laptop, so forgive me if I'm not.
Yeah,
If I'm
I
not
have
getting
it
it
here.
right
So I just want you to explain how you did it.
Okay. So
Yeah,
having
I have it here. I have
having
everything here.
arrived at the 21 people.
I think this thing is going.
Yes. I now went to and decided to read them. I decided to read the documents to find out whether they were talking about what we were looking for. So I was looking for barriers. I was looking for green building, and I was looking for Ghana.
Yeah.
And so if if the study does not concern Ghana, it is not talking about green building, and it's not even concerning the barriers, then it is out. So that was one of the criteria I was looking out for. And then accessibility, as in getting the paper. So I asked myself, am I able to get access to this paper? If yes, then I marked it, or I selected it. Then the second criteria was that it needs to show relevance. Relevance in the sense that it needs to be consistent with the theme. As I've said, Ghana challenges and then barrier, green building. So these ones needed to have been there. Yeah. So basically, that was what I did.
Okay,
So
good. Yeah, that's
a
good. Joshua, I think you also told me you went through it. Can you just also say something? Hello, Joshua.
Can you hear me?
Yes, we can hear you.
I think with regards to what he has said, he mentioned all, and what we also looked out for is the quantitative nature of the paper.
Exactly.
Because we need paper to do the meta-analysis. That's why we arrived at 13 articles.
Okay, great. So, Joshua, how many did you end up getting?
I think it was 13.
13. Okay. And Gosway had 9. Gosway, you had 9. Oh, sorry, you had 13 too.
I have 13. No. This is not.
This is not your Excel sheet. This is your Excel sheet. This is your Excel sheet. They actually 13, to be honest. I also got 13. I got 13, as Joshua rightly said. But I don't know whether Gosway, you have something different. If you have something different, talk about it before we move on.
Oh, no. Let's proceed.
Did you get 13 or how many did you get? We need to resolve this and see the difference because I think based on what you have recommended here, having 9.
Yes. Then, if this is what I sent you, then that is it. That was what I.
Yeah, you are having 9.
Yeah.
Joshua, yes. I mean, is there any other person who was able to do? Because we want to reconcile this. Because after today, there's no turning back, as I rightly said. We need to, we all need to agree on what we are doing. After this meeting, no turning back. But the next time is submission. There will be no turning back after today. Is there anybody who was able to do this so that we compare? Okay. Joshua, for now, we'll go by what God's way has done. Okay.
Okay, Doc.
Yeah. Joshua,
Please,
talk.
I wanted to ask a
Oh, no,
question.
okay, please. Yeah, please ask.
Yeah, aside the meta-analysis, which you said that one is based on quantitative method, like
Yeah.
with regards to the systematic literature review, like
Okay.
from what you were saying and what I did, aside you putting the keywords in the database, the process, is it all like subjective nature? Like, I don't know if that's the right thing.
Yes, I get your point. It's one of the biggest limitations of systematic literature review, and I'll say all literature reviews, not only systematic literature review, because it's subjective. Subjective in the sense that the keyword that you put in, it's possible you may not have captured all important keywords, and these things come up a lot when you get reviewers comment. Sometimes they even recommend some keywords for you to go and do the search again.
Okay.
So at the end of the day, yes, I agree with you that it's subjective. Subjective in the sense that you are putting in the keywords based on what you have read and based on what you know. But another person may also undertake a similar or the same thing, and the person will do something different.
Okay. Because
Yeah.
when I was doing my dissertation, I did that, and at the point of submitting my work, I wanted to cross-check either, okay, my supervisor may take my keyword to check either I did what I have written in my work. When I put the keyword in the same like scopus, I was having different papers. Yes, the numbers. So I tried doing my checks and search. So I found that maybe there have been some new publications and other things. That's why maybe it is changing. But I don't know.
I agree.
So
I agree with you. I agree with you. So it's one of the challenges, to be honest. It's one of the biggest problems that we have when it comes to undertaking a systematic literature review. Because even the database, as you rightly saw, you put a keywords here and this one will give you different results, and then you go here, that one will give you another results, another different set of results. So when you are writing, or when you come to the either the conclusion or in the process of writing the thing, you need to state these limitations clearly, so that anyone who is going to review your work will know that you understand what you are doing, because it's a normal thing that is going to happen to you. You are going to have different results. You are going to have different things. And because you are going to have different things, they will affect your outcome. Because you will use certain keywords, another person will come in and then use a whole different keywords, and the person will get different results, as you did. Yeah, so subjective, I would say yes, that's for subjective when it comes to systematic literature review. But in order to overcome the subjectiveness and the biases, that is why there are guidelines, and that is why mostly, or in all your systematic literature review, you have to state that limitation. And that is why we even have inclusion and exclusion criteria. All these things are ways to just reduce the biases and the subjective nature of the process. Because definitely you are going to have biases. Definitely you are going to have this kind of subjective outcome, because the databases give different results. And the keywords, you will not use all the keywords. You'll be missing some of them. Even sometimes some people don't even use the appropriate keywords. Yeah. Because if, for example, somebody decides to do a study on green buildings in Ghana, this same thing that we are doing, the person may get different results. The person may get different results. And the different results is all about how the person will approach it with the keywords. Okay, so we try to, but the biases are still there. The subjectivity of the whole thing, they still exist. But we try to cut down, reduce it to the barest minimum, the least, but still, and the biases and the thing, they are going to be there. So in your writing, state this, and also in the conclusion section where you state your limitations, state that as well. Yeah. Once you do that, you are going to be okay. Yeah, because you can't do away with them. They are going to be there. And there's no way you can eliminate them 100%. It's not possible. Yeah. Okay. So let's come back. So there's something that is going through my head, which I think maybe we have to do.
Hello, no.
See, I see. Please, someone's this thing is. Please mute yourself. Make sure you mute. You put your this on. You'll mute yourself. Okay, so I can see the drivers and the barriers going through the thing, and it seems the barriers and the drivers, the drivers ones are highlighted red, and then the barriers are black. Why don't we do the two at the same thing together? I mean, at the same time. I think we can do it, right? Even though our results will be big or will be massive, I think there will be nothing wrong with that in the same paper. I don't know. That's what I'm thinking. Instead of, because we can write an entirely new paper on only the drivers, the enablers, or the drivers, or the critical success factors, which I can see them from this list, and then the barriers. So why don't we do the two together and just call the meta-analysis on green building development or green building something in Ghana, where both the barriers and then the critical success factors have been analyzed using meta-analysis. That's what I'm thinking in a way. I don't know whether you agree with me. Instead of discarding the other papers, or writing an entirely new paper, because we can write an entire new paper only on meta-analysis of critical success factors of green buildings in Ghana. That would be an entirely new paper on its own. I don't know. That's what I'm thinking. What do you all think? Yes, Joshua. What's your view on this?
Thinking that we can combine it to make
Yeah,
it more.
that's what I'm also thinking, because instead of discarding one of them and then just focusing on this, I think we should do both. We should do both. But when it comes to the interpretation, if we can even combine all the two, both the barriers papers, and then we do one, then we separate them based on the barriers and then the critical success factors, and we also analyze that, which I think will be a good idea. Then we get different results. I think we should do it that way. Okay, so Gosway, take note of this. Gosway and everyone, please take note. And then after here, but right now I'm going to do the analysis based on what we have for the sake of time. Yeah, so that you do this later. Yeah. Okay, I'll also do the same. Then we go about it. Now let me come to the analysis. So with respect to the analysis, each of the articles, you need to, it seems this is the old paper, my paper, right? Oh. Bosway, this is what I did. Joshua, where is the one that you did?
Doctor, I wanted to tell you that I didn't do the analysis. I just got the papers.
The papers. Oh,
yes.
okay,
For
okay,
us
okay.
to agree, on them.
Okay. I get you. I
Yes.
get you.
So that was what I was explaining to you, that I didn't do 13.
Yeah,
I didn't get 13.
Yeah.
Yes.
Okay, I get you.
Doc,
I get
please, I would like to ask Mr. Ofori to kindly send me what he did, so that I'll.
No. I think he also didn't do it. Oh, Joshua, you did.
Actually, I based
take a
on
look
what
at
you
what he
did,
has done.
or I based on what you sent us.
Okay.
Because
You
the
did something.
email communicated that we should look whether everything is okay.
Okay. So
Yeah.
did you end up doing something, like doing some meta-analysis,
Thank
or
you.
you didn't?
No, I didn't go up to the meta-analysis section.
That's good.
It
Okay,
was
now
only the
let's
confirmation.
come there. Let's do this. So this is the meta-analysis. And with this meta-analysis, I want to once I recommended this last time, but I want to recommend it again. There is a paper which I want everybody to download. Okay. I want everybody this paper. It gives you the steps to how to do meta-analysis with Excel. This one, you don't even need the software. It was published in 2012 or so, and it has received quite a number of citations. I'm going to share it in the chat box. Let me share it in the chat box for you. And it's the same thing I'm going to do today. I'm just going to explain the steps to you. And then I'll take you through some few things. Then we are done. It's the same. Then I'll run. Oh, okay. Yeah. So you can unmute yourself or you can leave and come back again. Okay. Causeway, I agree. Okay. Yeah, you go and do it. Okay, so with the meta-analysis, so this is what we are going to do. So please get that paper. Get that paper. I've shared it in the chat box. So get that paper. Okay. Now let me take you through the steps quickly. And this is how I did it. So one, with respect to the factors. So each of the papers, when you open it, it will give you the number of factors, whether they are barriers or drivers. So let's pick one of the papers that if you pick this paper, for example, which was published or which has been published. Okay, that's okay. That's way. Which was published by Dr. Deborah. Deborah. Right? If you go through this paper, you can easily identify the number of factors that they utilize to undertake this paper. How many factors did they use? If you go through it, hello, please, there's somebody, you can unmute. Unmute yourself. Is it Joshua or one of you? Please. Okay, so when you go through this paper, for example, the number of drivers which was which they used for this paper, they are here 16. Okay, can you see that 16 the drivers? So if I am going to put this on this, I'll just put a 16. So if that's the first article, so here will be 16. The number of factors identified 16. So each of the papers that we are using, go through them and identify the number of either factors or barriers. Because we are dealing with both factors and barriers, I will suggest you create 2 columns, one for barriers, one for factors. And then you create a third column where you combine the two, both the drivers and the barriers. I hope you get what I'm saying. So if you pick the first article, which in this context, for example, let's assume this is the first article, which is from Dr. Caleb Deborah. Okay, how many factors is they used to do or to work on their resource? I think they utilized 16, and that we can see that 16 factors. Benjamin, can you see this?
Yes, please.
Yeah, so 16 factors. So 16 factors. So you put the 16 factors where? Here.
So,
Now the next thing, you can see?
Yes, please.
Can you see my screen or you can't?
Please, I can't see.
You cannot. You cannot. Really? Okay, let me do it again. Sorry. Let me reshare my screen. Can you see my screen now?
No, please. It's written there. Isaac is presenting, but it's not showing anything.
What about others? Please, the rest of you
can
see
see
my
it. I think
screen?
it's from it's from your this one. Check it.
I can see
Internet. Maybe check. Could be internet related issues.
Okay, let me rejoin again.
Yeah. Yes, please rejoin. So 16 factors were used. So you put a 16 factors here, right? Now the next thing is look out for the sample size. The sample size here represents the respondents. The respondents in this contest, in the study. So if you take Dr. Caleb Deborah's paper, now let's look at the number of people who responded to this survey where they use 16 factors. So you can identify this in the methodology section, or sometimes they state it in the abstract section. Let's try and see that. So how many people did they contact? Okay. So they use out of 30, okay. And total. So 12. 30 experts. So that means they use 12, right? Oh, I'm not seeing it right. No, is it 12? Okay, 12, yeah. Please, can you see that? Can we all see the 12?
Yes.
So the sample size in this contest is 12. So you put it here.
Yes.
Okay, so once you have the number of the number of factors identified, and then the sample size. Now, the next thing to do is you divide the number of factors by the sample size. Okay, the number of factors by the sample size. And that will give you what we call the effect size. The effect size. The sample, the drivers or the factors divided by the sample size will give you effect size. And as you can see, I've done that here. I've explained that this is B and this section is C. When you divide the C, you divide the B by C, you should get the effect size. And I've shown that B divided by C should give you this. Okay. The next thing to do is to find out what we call your standard error. What is a standard error? So I've also given the formula here. So for you to get a standard error, divide the D. The D is this column D. It is the effect size. Divided by the square root of column D times column C. The column C is the sample size. The effect size multiplied by the sample size, the square root of that. Or divided by this to give you the result. So now let me show you. So it's like this. Okay, D, which is the effect size. Okay, let me put it this way. So the effect size divided by the square root of the effect size times the sample size or the sample, the square root. The square root of the results that you get for multiplying the effect size by the sample size. That will give you what we call the standard error. Okay, so once again, as I mentioned, I got these ideas from here because I always want to show you the source. It's not like something that I came up with so that it will be like you are doing your own thing. And the good news is that the paper has also outlined the same steps. That's like what I'm explaining here. The same. They have explained it step by step. So please, I want you to get this paper. So how do you get a effect size? Is that the event within this context, the factors divided by the sample size? And they have done that. How do you get a standard error? That has also been explained. Okay, which is the effect size divided by the square root of the effect size times the sample size is also here. Or you can also use the square root of the event, which is the factors in this context, divided by the sample size. Any of them should give you the standard error. Okay, so what's the next step? The next step is to compute the variance. So the variance is simply the square of the standard error. So the result that you get for the standard error in step 2, you just square it, which I have done exactly the same here. So this is my standard error. And how did I get this? So you can see the square, right? This standard error square. And that will give you the results of the variance. You do the same. One good thing is that once you do it for one, you can drag it down. And it will give you the same results for the rest. So you don't have to waste too much time here. Now, what is the next step? The next step, step 4, is to compute what we call the individual steady weight. That's the weight, just like what we have done for fuzzy. So all these things that we have learned or we are learning, they are kind of related. fuzzy factor analysis and all, they are all related. They are all related. You know, in fuzzy we compute what the weightings. So here too, we get what we call the weightings or the weight of each of the study. How do we do that? So for you to get a weight, you just find out 1 divided by the square of the standard error. The square of the standard error is the same as 1 divided by the variance. Is the same. 1 divided by the variance, because there's the standard errors, the square of the standard error is the variance. So if you just divide 1 divided by that to give you the weight of that study. The weight of that study. So I've done the same also here. So you can see my weight, right? 1 divided by the variance, or 1 divided by the square of the standard error. Okay, that's cool. Okay, Joshua, that's cool. Yeah, we'll be closing soon anyway. Give me about 15 minutes. We should be done. 15-20 minutes. We should be done. But I'm just explaining these steps. So I want everybody to do it. After today, I've shared this thing with you, but you also try it based on my this Excel, and also based on this paper, the paper I shared with you. The steps are there. Do the same thing. It's not difficult, but if you don't pay attention and do this, it will be difficult for you to know it. Do it yourself and apply it to other studies.
Okay.
Now, once you get it,
please, have you shared this Excel document on the page?
Yeah, God's way. I'll let God's way share it again with you.
Okay, thank you.
I'll let God's way share it with you. Then you do it. It's once again, as I said, it's not difficult to do this because Excel will be doing this for you. So you don't really need to be somebody who is extremely good in mathematics. It's not. You don't have to have extreme. You need not to be extreme statistics person or mathematics person. You must be able to do this. This is the basic statistics. Okay, good. So once you have the weight, the next thing is to also find out what we call the weighted effect size. Now that we know the weight of each of the studies, we need to apply it to the effect size. So what we are going to do is that we'll multiply the weight by the effect size, column D. We'll multiply column D by column G, right? Column D, which is the effect size, by the weight of each of the studies. And that will give us what we call the weighted effect size. Now, the next thing to do is to also find out what we call the square of the weighted effect size. In other words, we are trying to find out how they will work if we try to apply them to each of the studies. For you to do that, it's this same approach. It's the same thing that we did, but just that here, you just square the effect size. You only square the effect size. It's the same, but you just square the effect size. The weight times the effect size, but the effect size is squared. Okay, you do the same for the rest. Now you only find out only the square of the weight. You also want to see how the magnitude of the weight will also work. So you just find the square of each of the weight. You do the same, and then that will be the end of it. We will come back to this, or I'll come back to this for us to do this, because there are 2 models in meta-analysis. One is called the fixed effect model, and then we have the random effect model. We'll come back and look at the random effect model. Okay, so that's the first part. Another thing that we need to do is to know the sample size. The sample size, I mean, the number of papers that we are using for this meta-analysis. The question that somebody will ask is, how many papers are suitable for meta-analysis? According to studies, according to previous studies, if you have just two papers or more, studies which were conducted with quantitative design, if they are 2 or more, they are acceptable. You can use them for meta-analysis. So having 13 papers, yeah, a lot. So that's one good thing about meta-analysis. Unlike systematic literature review, where if you use 2 papers, a lot of reviewers will question you. With meta-analysis, you can use 2, 3, 4, 5, 6, 7, 8, 9, 10 papers to do meta-analysis. Okay, so the sample size in this case is 13 papers, as you can see. Now we find the degree of freedom of that. The degree of freedom will just be the sample size minus 1, which will give us 12. Now we look out for the Q. The Q and the I will help us to know the heterogeneity. And what is this heterogeneity? The heterogeneity will help us to know whether the papers are related together or they are not related. I mean, when I say they are related, it's more like correlation. Are they correlated or they are not correlated? And that one is determined by the Q and then the I. Okay, so I just want to show you something then. We read about that briefly. Okay, good. So as you can see, the Q and the I is this, it's just a sign to show, but it doesn't mean anything. So the heterogeneity refers to the variability in terms of how related or how they are not related in terms of the papers between the study result that goes beyond what is expected from a random chance. This inconsistency can be caused by differences in study populations, interventions, methodologies, and outcomes. So the reason why maybe some papers may not be related, or some of the results or some of the figures that you are looking at may not be the same, is that we all know that studies use different sample size, they use different population, they use different methodologies, they use different approach to even analyze their data. If you look at Dr. Caleb Debre's paper, they use what we called what is it, DEP something. They use a different method in terms of the data analysis. Let me look at. Yeah, they use the Delphi. Is it Delphi? Fuzzy Delphi, the mantle process. You also look at another study where the scholars have used factor analysis. You look at another study where the scholars have used AHP and the rest. So due to these differences, there is a possibility the outcome of the meta-analysis will be different. Okay, so we test that. We test the heterogeneity or homogeneity. The word homogeneity means they are the same. Homo, you know, Homo sapiens. Oh, is it Homo sapiens? It's Homo something. You know, Homo means they are the same, but when hetero means there's variability or differences in there. How do you test that? It's something very important that you have to test. And based on the testing of the heterogeneity, we will know whether your model fit into what we call random effect model or fixed effect model. Okay, so when your heterogeneity is too high, then we assume you are dealing with what we call a fixed effect model. But when your heterogeneity is too low, then we assume you are dealing with what we call random effects, which you can read about that. But the question that somebody will ask is, does it really matter? I would say no, it doesn't really matter. It's just the outcome of the model, but you just have to explain. It doesn't really matter much.
Okay.
The outcomes.
Okay, so
Go ahead.
you were saying either too high or too low. So is there a boundary to check either it is high or low?
The boundary, I would say 75%, 70% and above, or 75% and above.
Oh, okay.
Yeah, 75. And I'm basing this on just the normal threshold for factor loadings. Factor loadings. Benjamin, do you still remember the factor loadings? 0.7 and above. Oh, you don't?
Yes, please.
Yeah, so Yeah, so when your factor loadings are 0.7 and above. Yes, but once again, I would say check it from 0.7 and above. But I know some studies put it at 0.5. 0.5 it's low, it's just not. Yeah. Okay, yeah, so that's it. And there are also other interpretations as to what makes the fixed effect model different from the random effect model based on some other characteristics and assumptions. Okay. Now let's come to how do you run this? Now we have all these results and the order. How do you run this in the Jamovi to produce what we call the forest plot and other things that will give us a better picture of how the results went about? You can do this once again with the Excel. But to do this with Excel, it will take some time and you need to learn some Excel features and all that, which I think is quite difficult a bit. It doesn't mean you can't learn, you can, all right? But if you follow these steps, you can do it. But I personally believe that you need to use the software to make your life easy or to make things easy for you. That's what I recommend. Okay, but you can decide to learn the Excel steps and do it, which sometimes is a bit confusing. It will take time and you may not get the right results, but the software to give you accurate outcome. Okay, so that will lead us straight into the software, and the software that we are using in this context is called Jamovi. The question that somebody will ask is, can I get this software? Yes, it's free to download. So everyone here, you can download Jamovi for free. It's a software. Download it. It's used for meta-analysis. Please download it for free. But if you want a more robust user subscription one, you can go for what we call Cochrane Refman. Yeah, you can go for Cochrane Refman. Okay, but that one comes with a subscription, which like you have to pay. If you want that, you can use that. That is what most scholars in the past, and especially those in the medical field, most of them, that's what I see they use. Most of them use this. But my only issue is the price and subscription. That's my only issue. But it's almost that's the same thing as the Jamovi. But the Jamovi is free. So please, it's up to you. You have to make a choice. But I would recommend go for the free one. Maybe in future, if you want to buy some to purchase the Refman, you can go ahead and do it. Okay, so when you come here, you click on download and install Jamovi on your computer. So you click on that, follow the steps, and you install. So when you install and you click open, this is where it will take you to, or it will bring you. Great. Now, there are a number of meta-analysis techniques in the Jamovi, and they are here, as you can see. If you click on measure, we have 1, 2, 3, 4, 5, 6. There are 6 different categories of meta-analysis. They are all meta-analysis, please. All of them, the results, they are acceptable. But it will come down to the kind of variables and the data that you have. For example, if I take the correlation one, that means I must have a data, or one of my variables should be about correlations from the papers. And then I must have my sample size, just like how we identify with this one. And then I must have my moderators. And then as for this is just for the names of the papers. I must have all these things before I can use this type of meta-analysis. It's a type of meta-analysis. Now, if you come to the second one, the same. Also here, there are variables or some data that I need. And one of them is the number of incidents in the experimental group. I think this to me, this will go more for those in the medical science field. But we can also use it if we have the data. It also can be done. Okay. The number of incidents in control group, the sample size for experimental group. If we have this information, we can put them here. And that will also give us a better analysis. Another one is this one. This is actually the one that we are going to use because this is the information that it seems we have, which I'm going to copy and put them here so that we use it. And that has to do the effect size, the variance. We have the effect size and variance as far as our this thing is concerned. So I recommend we use this. Then another person can use the mean one. With the mean, you need group 1 sample size, group 2 sample size, standard deviation, and the rest. If you have this information, which I think maybe another time that we meet, we can do this. We can look at this, looking at the differences between two groups. Then proportions. If you have frequencies of the event, total sample size, this, you can do this meta-analysis as well. And then we have reliability generalization. If you have the Cronbach alpha, number of items, sample size information, you can also use this to do that. So please, these are the various types of meta-analysis. Any of them that you use is correct. I don't want you to say that maybe the JAMOV is only one meta-analysis type that you can conduct. They have, the JAMOV has six different meta-analysis categories, but they will all come down to the data sets, the variables that you have. In our context, the reason why I'm selecting this is that we have information about our effect size, and we have information about our variance and our standard error. Okay, so without wasting time, I'm just going to copy the information because we are going to use the third one, which is about effect size, variance, and standard error, which we have. So I'm going to copy that. So I'll go straight into the Excel sheet and then take hold of my sample size, the effect size, and standard error. Is that the case? No, I'm wrong. Let me check again. I want to confirm. Effect size, variance, and standard error. Okay. Effect size. So I need to select effect size, standard error, and the variance. These are the information that these are the things that I need. Okay, if I want to run this type of effect size, variance, and standard error or standard error. Yeah, so these are the things that I need in order to run this category of meta-analysis. So I'm going to put them here. I'll put something there from the beginners. So I want to put this one here. Okay. Now I want to just copy the the labels because they will also be needed. I need them. I need the labels. In other words, the steady name. I'll put them in the first row. And I'll just delete the first, this side. I'll delete the first row. Why? Because we don't need a first row. Oh no, why is it not didn't go? Yeah. Okay. Now the first row, the first column is about the studies. This is the articles, article 1, 2, 3, up to 13. For that, it's a nominal. It's a nominal variable. So it's just something. So you can name this the article. You can say articles or the studies. Any of them is acceptable. And then what next? The next one is the effect size. Don't forget. That's what we copied. This is the effect size. And the effect size, we have to maintain the effect size as what continuous, right? Even this one, we can maintain this as an ID because this is not, it's not really a variable. It's just an ID showing the studies. It's not really something that contains numbers or something. Now, the next one is the standard error. And that one to the same. Yeah, the next one is the variance, the var. So the var here represents the variance. Okay, so I have the important information that I need for my meta-analysis. The next thing is to go to where the analysis is, the categories of analysis, and select my type of meta-analysis I want to run. Oh no, I think I've made a mistake. Okay, let me go back and just change this. But it seems it's not picking as an ID. Let me make it as a nominal. Okay. So I come back. I take my effect size. So here, the study label. It's just a study label. It's supposed to be ID. I don't know why I didn't pick as an ID, but just let's put it that way. That's not the most important because that one will not be the part of the analysis. This is just about the main analysis will be dependent on the effect size. So you click on this and put it here, and then one of them. So here, either we put in a variance or the standard deviation. You can't put the two in there. You have to select one. Okay, pick one of them. So let's say the variance. Once I put in the variance, the results will automatically be generated. It's generating on your right-hand side. Can you see? So the results has been generated. So this is the results that we have. Okay, now let's look at the interpretation of the outcome. It seems we are having a high heterogeneity. And once you have a high heterogeneity, then the effect size, the fixed effect model will not work, rather random effect model. So I'm not surprised that the outcome is showing a random effect model, the outcome. Okay, because our I is very high, which is 97.39%. Okay, now this estimate show the significance, which is kind of the coefficient of the relationship between the studies. The relationship between the studies. Here we are saying that the studies, the coefficient is 0.117. And the question is it significant? That's the next question. Yes, it is. That means our resources, even though the kind of relationship, the kind of effects that the variables, which in this context, let's assume that the barriers, if they are looking at barriers of green building, the effect size is not that strong because it's 0.117 is not that big. In percentage wise, this is 11.7%. But when it comes to its significant, it's significant. Why? Because it's less than 0.05, same of the significance level. But the only issue is that it has a high heterogeneity. The variances between the studies giving us this resource is too wide. It seems the papers are saying different things. They are not homogeneous. They are not saying the same thing. Yes, we are getting this kind of resource, but the variability, the differences in how these studies see the barriers of green buildings in Ghana are different. So that's the interpretation that you will give. Now let's look at the forest plot and what we called the funnel plot. The funnel plot will give us what we call publication bias. Here, the publication bias is clear. It seems that they are not all converged under the funnel. I'm talking about the point, which is the papers. It seems they are scattered, which in a way goes to show the variability of the papers, where we're having 97.39%. Yeah, it seems the papers are saying something different. And because of that, there is some level of bias. The bias in this context means that some of the papers are extreme. They are giving extreme outcome, while some are giving moderate outcome, and while some are giving just normal outcomes. Yeah, and this has also been explained here using the publication bias assessment. Yeah, so any question? And then this gives us the confidence interval of each of the papers, the articles, how they see these results. So out of the results, these are each of the, if you are going to analyze each of the papers, this is how they went about it. I think if you go through them, is the paper number 10, which has the highest, which is 0.34, it's about 34%. And the one that recorded the lowest is paper number 11. And because of that, if you even look at their confidence interval, it seems they have a negative lowest limit, and then the highest limit is 0.02. Yeah. So that is how it is done. So normally when you are writing the meta-analysis, you have to copy all these results. So you copy the random effects, you copy the heterogeneity, and then you also copy the forest plot. Okay, the forest plot. And then you also copy the publication bias in addition to the funnel plot. The funnel plot and the publication bias, they go together, and then you interpret them. So that's how they are presented. Okay, anyone with a question?
Okay, so thank you, Doctor. I think today I've learned something new. So like I wanted to know something. When you were speaking, you mentioned some methods, something like AHP and the Fuzi Damate or something. So for the AHP, I know the main idea is to maybe when you take factors, you want to know, seek the level of importance from maybe experts according to. So with this meta-analysis, all this analysis we are doing, what is the main ideology? Like, what do we want to get?
The main motive is to actually, as I explained it the other day with the other student, the main reason why we do meta-analysis is to find out an objective outcome of your literature review. Meta-analysis, don't forget, is just like a systematic literature review, but normally, a normal systematic literature review tend to be more qualitative inclined, and qualitative studies are more subjective.
Okay.
But with the meta-analysis, we are trying to arrive at a result which is objective based on our review.
Okay.
An objective outcome. Yeah, so that is why most studies, after they have conducted their normal qualitative systematic literature review, the meta-analysis will do that to establish the objective outcome of the same results or similar results related to it. So that's why meta-analysis are done. Not just because we want to compute figures, but we want to get an objective quantitative outcome of a phenomenon. Is that okay?
Yes, please. That's okay. Thank you.
You are welcome. Any other person who has a question? Yeah, you can go ahead if you want to say something more. Talk.
Doc,
No,
please,
I wanted to say like I will go through the document to like make myself better on this methodology. Yeah.
Okay. Yeah. Okay. Yes. Who? Somebody is talking. Yes. Is it Elvis or Bismarck?
Bismarck, Doc.
Okay.
Doc, please, was the class recorded?
Yes. I've recorded everything.
Okay, please, kindly share for us.
I'll share. Yes, I'll share.
From the beginning, I I was on my way to the office, so I couldn't get
Get
lot of
that.
things.
Okay. Yeah, I'll share. But I want to just explain one thing from one paper, and then we are done. Our time is actually up, but just give me about 5 minutes. Based on this, the results I've just shown to you, I just want to show you a paper that was written. Last week, I mentioned that please, all of you try to refer to meta-analysis from the medical science field, because in the medical science field, most literature reviews have been conducted using meta-analysis. And I would not say that that's where meta-analysis came from, but it seems most studies on meta-analysis are done in that field. So they have a lot of papers on meta-analysis. So if you really want to be a good person, an expert, a guru in meta-analysis, learn from there. Learn from them. Okay, those in the medical science field, yeah, they have a lot of meta-analysis papers, and most of them are easy to read, easy to understand, follow. So one of the papers is here, just like what we are doing. And in this paper, they also conducted a similar thing that we have just done. And this is the results that they got. So if you look at their results, it's showing that I want to read something. Okay, so from the results, they are saying that the poor prevalence of adolescent and youth-friendly health services utilization in Ghana stand at 42%. This is 95% confidence interval. That's a similar thing that we go for ours, just like ours. You know, I mentioned that to you. So here, 11.7%. 11%. If we were going by that, 11.7%, and then the eyes square will come in 11.7%. For them, they got 42%. The higher the rate, the higher the better. But it doesn't mean if you get a lower outcome, it doesn't mean your paper is not good. Or I mean your outcome is not good. It all depends on the context and how you explain it. But in this college, they go 42%. It is important to note that the analysis reviews significant heterogeneity as confirmed by the I-square of 88. So for them, they got an I-square of 88.95%. And then the chi-square test of x square of the chi-square of 60.33%. To account for this heterogeneity, a random effect model analysis was employed. Yeah, always when your heterogeneity is so high, the random effect model is better, was employed, ensuring that the data accounts for variability between the studies. So as you can see here, based on your I-square, the I-square, the heterogeneity, the software will automatically tell you the kind of model which fits for your study. And this one, I'm not surprised the software automatically gave us random effect model, because our heterogeneity is very high, 97.39%, getting to almost 100%. That's very high. Okay, additionally, an assessment for publication by using the Eggers regression test yielded a p-square of 0. This result indicated the absence of publication bias. Publication bias. Let's look at the publication bias in the analysis, suggesting that the findings are less likely to be influenced by the selective publication of studies. Okay, let me look at that. What is the Eggers square? Okay, they got 0.314, and was this significant? So it was not. Now let's look at ours, and also with the first plot, and then the final plot. So the Egger one, okay, is also significant. Okay, then that means ours, there's also no publication bias. Ours too, there's no publication bias. That's what this one is also saying, because we are getting less than 0.01%. This is significant. Significant means there's no publication bias. But if it turn out to be the opposite, then there is publication bias in this context. So, well, even though the results are scattered, but it's saying there's no bias, so we'll take it as a test. What again do you have to check? Yeah, I think that's the main thing that they checked, and then they went ahead to add the factors. For them, they even did thematic analysis, which is qualitative, and they also did the meta-analysis, which is quantitative. So they combined the two. So you can see systematic review and meta-analysis. They combine the two. They combine the two. Yeah. Maybe in our case, we can maybe do the same, where we identify the barriers and yeah. Any question? Any question from anybody? Yeah. So before we go, Benjamin, Joshua, and Gosway. The rest of you can do it, but these three people, please, I want you to send me your results by the end of the weekend. These three people, just send me your Excel results plus this. I just want to see something, how you went about these, you three people. The rest, please, you can do it at your own leisure time. And then I will share the work as to what each and every one. I think the work has already been shared, if I'm not wrong. Bismarck, do you know what you are doing, Elvis? But we have to add the new ones who just came in, Gilbert and Noah. They have to also write part of it. Yeah. So I think that is all from me for today. If no one has a question, then we will end here. If nobody has a question. Joshua, do you have a question? Benjamin, any question?
No, please.
Okay.
No, please.
Okay, then. I wish everyone the best. Yeah. Joshua.
The
Thank you very
part,
much, John.
the part I'm
Joshua.
going to do, like, how will I know it? This Noah.
Noah, okay, I'll put it on the page.
Oh, okay.
Yeah, Noah and Gilbert. This you have to do something. So I'll put it on the page, then you do that. It's just everybody's going to write something small because this one, I don't want people to be writing too much. Maybe maximum 500 words, 500 words, or maximum 700, maximum 700 words each.
That's going to be like 2 pages or something. Okay.
Yeah, 700 words. I think 700 words should be about 2 pages, if I'm not wrong.
Oh, okay. Oh, okay.
2 pages. Yeah. Okay, everybody, all the best.
Okay.
I'll send the video. You can watch it again, and also watch the previous ones and practice. The main thing is about practice. If you don't practice this thing, you are not going to get it. Practice. If you practice, you do 1 or 2, it will be easy for you. That one I can assure you of that. If you do it, just go through these steps and do it as I have done it. Easy. You can do the rest your own way, your own style. You can write so many papers out of this. I want you guys to be using meta-analysis because when you use meta-analysis, it's like you have a higher value in terms of your paper being accepted compared to somebody who is doing a normal systematic literature review. It doesn't mean that if somebody does systematic literature review, the person paper will not be accepted. That's not what I'm saying. But I'm saying that somebody who has done or is doing a meta-analysis, your paper carry weight. You have more value in a way. Anyway, I may be wrong in a way, but I'm just saying. Yeah. So I want to encourage everybody to be using meta-analysis in addition to your systematic literature review. Yeah, because most people don't use meta-analysis. Many people do normal qualitative systematic review, and that's the end of it. Yeah. So make your paper different. Just be ahead of the game and stand out. All the best. See you. Bye-bye.
Thank you.
Thank you, Doc. God
Thank
bless
you.
you.
God bless you
Thank
too.
you.
Bye. Bye.